We're going to look at how to actually create a Bohr model using a periodic table and using that information in order to construct the Bohr model. Okay, so first let's start by selecting an element. So I'm going to go ahead and start with hydrogen. Okay, so hydrogen is a pretty simple one. So hydrogen, and if we look at the periodic table, hydrogen has the atomic number of 1. Okay, we'll say that the atomic mass of this hydrogen is 1, and it's going to be a neutral hydrogen atom. Okay, so if we look at the model that is structured, in the center, we have our proton and our neutron number. Remember, that makes up the atomic mass of the object. Okay, so our proton number is going to match our atomic number. So we have 1 proton. And because our atomic mass is 1, it means that we have no neutrons, so 0 neutrons. Okay, because this is a neutral atom, the amount of electrons is going to match or equal the amount of protons we have. So we're going to have 1. Now, whenever we go to draw in our electrons in the different energy levels, we're going to start with the first energy level. And you should have seen on the previous slide that the first energy level is the innermost energy level. So we're going to go ahead and put our 1 electron on our first energy level. Okay, so that is the Bohr model for hydrogen. Okay, let's try a different element. Let's go ahead and do argon. Okay, so for argon, it has 18. And let's say that it has an atomic mass of 8, or atomic number of 18. Let's say its atomic mass is 40. Okay, and we'll say this is also a neutral atom. Okay, so starting in the center, our protons is going to match our atomic number, so 18. Okay, for our neutron number, we're going to take the atomic mass, which is 40 for this particular argon atom, and subtract the amount of protons, so 40 minus 18, and we're going to get 32 neutrons in this atom. Okay, it is neutral, so we're going to have 18 electrons as well. So I'm just going to kind of write it over here so that we remember, because it's neutral, we're going to have 18 electrons. Okay, so like we did before, we're going to start with the first energy level. So first energy level, it can only have 2 electrons. Okay, the second, before it's full, can have 8 electrons. And then the third, for the purposes of making Bohr models, also gets full at 8 electrons. Okay, so let's go ahead and start with our innermost. So the innermost can have 2. Now, it is good practice to kind of couple up the first 2 electrons in the first energy level. So I'm going to go ahead and couple them up or pair them up. Okay, now for the second energy level, so now we have 2 electrons, but we can't put any more electrons into the first energy level, so now we have to move on to the second energy level, which can accept 8 electrons. Okay, so we have 2. Now what I'm going to do is I'm going to put my electrons in the cardinal direction, so the north, east, south, and west directions, and I'm going to go around. I usually go around clockwise, you don't have to. But I'm going to put them as singles, and then I'll pair them up as I go around. Okay, and this will be more helpful whenever we actually do Lewis dot diagrams. If you start making a habit of doing this, it'll help whenever we get to covalent bonds and things like that. Okay, So I have 2 electrons already, and I'm going to put 1, 2, 3, 4. Okay, now I'm going to cycle back around, pairing them up. 5, 6, 7, and 8. So that one is now full. I can no longer put any more electrons in that level. So now I have to go out to the 3rd level. And once again, I'm going to go around the energy level and then pair them up. So far I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I need 8 more. So 1, 2, 3, 4, 5, 6, 7, and 8. Okay? So that is the basics of how to do the Bohr model. Okay? If this was, so let's say that this was argon, which this wouldn't happen in nature, but let's say we had an argon whose charge was plus 1. Okay, that means it would have 1 less electron, so it would only have 17 electrons in order to give it that positive charge, because remember, we can't change the proton number. Okay, so in that case, we would have 1 less electron, so I'm going to go ahead and erase that electron and draw back in my energy level here. It's not going to be as nice of a circle. Okay, so there it would only have 17. So be aware of that. If it is a ion, make sure that you are looking at what should the electron number be before you start your Bohr model.